Hello. Hello and welcome to this video. In this video, we will quickly go through UID functions and XML functions a bit. XML functions is quite a bit of documentation, so it will take a bit of time, maybe 2, 3 videos to finish that. So let's start with UID functions. And one more thing, I would say that if you're watching this playlist, then you would know that in previous video, I have shared a gist of roughly 3,000 odd long script. So please go through that, run the gist. Let me show you the gist for full text search. Gists. Okay. So what I was talking about is this. Okay. FT stuff, and it is quite big. So I expect and hope that you have gone through this and run all the examples, because that's what will help you in getting proficient with full text search functionality of PostgreSQL. So UIDs are relatively simple. So table 9.45, that is this table, shows the PostgreSQL functions that can be used to generate UIDs. Now UIDs, as you know, are 444-bit, sorry, 128-bit. So let's run this and okay, we put here the select or simply say info. Whoa, then UI. Why it is not working? Select has to be there. Okay, so this is the UID which you get from this function. If you want to generate UID4, you can do that as well. UID4, UIDv4. That gives you version 4 UID. Okay. Now, quite recently, UID7 has become part of Postgres. I think it was introduced in version 18. So if you want a sorted column for your family key, specifically time order, these are time ordered. So I would recommend that you go through the documentation of UIDs so that you see how we can order this. So the simple invocation will mean that let's say 7, and you will have a version 7 UID. I believe 48 bits are for time ordering, so you can do that. Now this optionally receives an interval. The timestamp is computed using Unix timestamp with millisecond precision plus some millisecond timestamp plus random. The optional parameter shift will shift the computed time by the given interval. The UID OSSP module provides additional functions that implement other standard algorithms for generating UIDs. Now we have UID extraction functions. So the first one is UID extract timestamp. So we'll see that. Let's do that. Select we want to extract timestamp from this one. Okay. And let's see. So you see the timestamp 8th of July, and it is 6:31 because it is taking the UTC time zone. Right now it is midnight for me, so 5.5 hours of difference. So extract the timestamp which time zone from a UID version 107. For other versions, this function becomes small. Note that the extracted timestamp is not necessarily exactly equal to the time the UID was generated. This depends on the implementation of the generated UID. UID extract version takes a UID and gives a small length, extracts the version from a UID of the variant described by RFC 9562. For other variants, this function return out. For example, for a UID generated by genRandom UID, the function will return 4. Now there's a footnote associated with it. Let's see what the footnote says. So it takes us to the actual RFC of UIDs. Okay. So if you want to investigate this, you can read this, or if you want, you can download PDF of this and go and read the PDF of the RFC for UID. So RFC 9562 will cover all the UIDs 1, 2, 3, 4, 5, 6, 7, 8, and so on. Plus there are nil UID and max UID. So it is a good reference. Go through it. It will help you deepen your understanding of UIDs. Okay, we put it. And PostgreSQL also provides the usual comparison operators shown in table 9.1 for UID. See section 8.12 for detail of the data type UID in the PostgreSQL. We have already gone through both of them. So now we will start with XML functions. Now, if you look here, XML functions are roughly 15, 16 pages. So it will be a while before we complete this. And in 3, 4 days, maybe 3 videos. So let's get started. The functions and function-like expression described in this section operate on the values of type XML. See section 8.13 for information about XML type. The function-like expressions XML parse and XML serialize for converting to and from type XML are documented there, not in this section. Use of most of these functions require PostgreSQL to have been built with configure with libxml, producing XML content. A set of functions and function-like expressions is available for producing XML content from SQL data. As such, they are particularly suitable for formatting queries, results into XML documents for processing in client applications. So first we have XML text, which takes a piece of text and convert it into XML. So here we have some text. We will see this. The function XML text returns an XML value with a single text node containing the input argument as its content. We define entities like ampersand, left and right angle brackets, and quotation marks as state. So see, if you do this, it will escape certain things. It will escape the angular brackets, less than and greater than, and ampersand along with quotes. XML comment. It also takes a piece of text and returns a XML. The function XML comment creates an XML value containing an XML comment with the specified text as content. The text cannot contain minus minus or individual minus. Otherwise, the resulting construct would not be a valid XML comment. If the argument is null, the result is null. So, for example, this particular query will convert this into a comment. Then we have XML concat, which takes some XML and variable arguments. The function XML concat concatenates a list of individual XML values to create a single value containing an XML content fragment. Null values are omitted. The result is only null if there are no null arguments. So, for example, if you concatenate this, so we have here self-closing tag ABC, then we have tag bar. Inside tag bar, we have value foo. So, querying will give you the same result. XML declaration expressions are combined as follows. If all argument values have the same XML version declaration, that version is used in the result, else no version is used. If all argument values have the standalone declaration value yes, then that value is used in the result. If all argument values have a standalone declaration value and at least one is known, then that is used for the result. Else the result will have no standalone declaration. If the result is determined to require a standalone declaration but no version declaration, the version declaration with version 1 will be used because XML requires an XML declaration to contain a version declaration. Encoding declarations are ignored and removed in all cases. So for example, we have this XML piece with version 1, then we have a tag foo, self-closing tag, then we have version 1.1, and it is not standalone, and we have bar as a tag. So we are trying to concatenate this, and it will concatenate this with version 1.1. Okay. Then we have XML element, which takes a name argument and XML attributes and their values, and then content and so on returns an XML. The XML element expression produces an XML element with the given name, attributes, and content. The name and attribute name items shown in the syntax are simple identifiers, not values. The attribute value and content items are expressions which can yield any PostgreSQL data type. The arguments with XML attribute generate attributes of the XML element. The content values are concatenated to form its content. So here we have name foo. Sorry. So the tag name is foo, it produces foo. Then we have name foo, and we have XML attribute xyz as bar. So bar is the attribute name and xyz is the value. And here we have current date as bar. So this is a PostgreSQL specific stuff. So it will put the current date, and content is, and then we have content, which will be the content concatenated. So let's see this example. Easy copying and pasting requires no effort. Element and attribute names that are not valid XML names are escaped by replacing the offending characters by the sequence underscore x h h h h underscore, where h h h h is the characters Unicode code point and hexadecimal notation. For example, select XML element. So here ampersand is problematic, so it will be replaced by the hexadecimal Unicode, rather Unicode code point of ampersand, which is 26 index. An explicit attribute name need not be specified if the attribute value is a column reference, in which case the column's name will be used as attribute name by default. In other cases, the attribute must be given an explicit name, so this example is valid. We have create table test XML bxml, and then we select from the XML element name test XML attributes AB from test. Let me see if I have. No, we already have the test database, so we connect to test, and we create this table there, and then we select this. So A and B attributes will be pulled from this. Okay, so it is empty, so that's why they're not now, but these are not. So this example is valid, but this is not. Select XML element name test XML attributes constant A comma B from test. Select XML element name test XML attributes from A comma B from test. Element content, if skipped, will be formatted according to its data type. If the content is itself of type XML, complex XML documents can be constructed, for example. So we can run this, for example. So we have first XML attribute is bar and value is xyz. Then we have name ABC, which is a self-closing one. Then we have test comment, and then we have name xyz, which will be a self-closing element. Content of other types will be formatted into valid XML character data. This means, excuse me, this means in particular that the characters less than, greater than, and ampersand will be converted to entity. Binary data type white array will be represented in base 64 or hex encoding depending on the setting of the configuration parameter XML binary. Particular behavior for individual data types is expected to evolve in order to align the PostgreSQL mappings with those specified in SQL 2006 and later as displayed in section Appendix D 3.1.c. Then we have XML forest. So it takes content as name and variable arguments and returns an XML. The XML forest expression produces an XML forest sequence of elements using the given names and content. As for XML element, each name must be a simple identifier, while the content expressions can have any data type. So we have ABC as full, 123 as bar. So this will produce ABC as the content of foo tag and 123 as the content of bar tag. Then we have XML forest table name, comma column name from information schema dot columns. The table schema is pg dot. So for example, let's run this, it would be interesting. Okay. And before doing that, we need to connect to Postgres and do this. You see, it produces quite interesting stuff. We have table name, PG large object, column name, data. Then we have PG statistics, table name, and column name is stat attribute num. Then we have stat inherit and so on. So there are lots of things here. So many columns are there. Huge number of tables and columns. As in the second example, the element name can be omitted if the content value is a column reference, in which case the column name is used by default, otherwise the name must be specified. Element names that are not valid XML names are escaped as shown for XML elements above. Similarly, content data is escaped to make valid XML content unless it is already of type XML. Note that XML forests are not valid XML documents if they consist of more than one element, so it might be useful to wrap XML forest expressions in XML element. Then we have XML PI or PI. The XML PI expression creates an XML processing instruction. As for XML element, the name must be a simple identifier, while the content expression can have any identifier. The content it presents must not contain the character sequence question mark later than. So if you want to see this, we'll see it produces the PHP hello world program. Then we have XML loop, which takes XML version, standalone, and so on. The XML root expression alters the properties of the root node of an XML value. If a version is specified, it replaces the value in the root node's version declaration. If standalone setting is specified, it replaces the value in the root node's standalone declaration. So we have a document with XML version specified and a content tag with ABC version 1 and standalone. So if you see this version 1.1 is replaced by 1.0 and standalone we have yes and content is now as it is. Then we have XML aggregate or AGG. The function XML AGG is unlike the other functions here an aggregate function. It concatenates the input values to the aggregate function call, much like XML concat does, except that concatenation occurs across rows rather than across expressions in a single row. See section 9.2.21 for additional information about aggregate functions. We will go and look at aggregate functions once it is there in order. So we have create table test y int x XML, insert into test values so and so, and then we do XML aggregation. So it does across the rows. So foo and bar both are concatenated here. To determine the order of concatenation, an order by clause may be added to the aggregate call as described in section 4.2 functions. For example, we can order by y descending. So y will come later here. Okay, this has come later, and if you order by ascending, then will come before that. The following non-standard approach used to be recommended in previous versions and may still be useful in specific cases. Select XML aggregation X from select star from test order by y descending as star. So we have that result again. Now I think I'll stop here and we will resume in the next video at 9.15.2 XML predicates. So I hope that you are enjoying this video and finding the video useful. And at the end of XML documentation, I'll give a comprehensive example, just like I did for full text search. So wait for that. Once we finish the read through of this section, the example will be given. So I will end this video here and we'll meet again in the next video with continuing our discussion on XML functions. So thanks a lot for watching. I hope that you have a nice day and enjoy.